All right, today we're diving deep. We're going inside one of the most violent and honestly most fascinating spectacles nature has to offer, the tornado. Yup, tornadoes. You're looking at these swirling columns of air that are just the definition of raw power. They can cause incredible destruction for sure, but they also teach us some amazing things about our atmosphere. So it kind of makes you wonder, right? What's the actual recipe for a storm like this? Okay, first things first, the recipe for a tornado. And believe me, it's not simple. You need a very specific, almost perfect, and very volatile mix of ingredients in the atmosphere to cook up one of these storms. So, what has to happen? What conditions need to line up just right for the sky to unleash this kind of force? Let's break it down. It really all boils down to three key things. First, you need instability. So picture this. You've got this warm, humid air sitting near the ground. That's your fuel, and it wants to rise. But then you've got cooler, drier air up high pushing down on it. The third, and this is the real game changer, is something called wind shear. That's just winds at different levels blowing in different directions or speeds. And what that does is it gets the air rolling horizontally, like a giant invisible log in the sky. Now, where do all these ingredients come together? Well, it happens inside a very special kind of storm cloud known as a supercell. And a supercell isn't your average thunderstorm, not even close. We're talking a massive, rotating monster of a storm. It's basically the factory where tornadoes are born. Okay, so we've got this spinning storm, but how do we get from that to the monster we all recognize? Well, that giant horizontal rolling tube of air we were just talking about, it's about to do something pretty dramatic. This right here, this is the tipping point. The storm has this super powerful updraft, right? That column of warm air shooting upwards. Think of it like a giant hand reaching down. It literally grabs that horizontal spinning tube of air and yanks it upright. And just like that, the rotation isn't sideways anymore, it's vertical, pointing straight down at the ground. And the moment that rotation goes vertical, you start to see it. A funnel cloud starts to snake its way down from the bottom of the storm. I mean, this is that classic, terrifying sight you see in the movies, right? The storm is literally reaching for the ground. But here's a super important detail. It's not officially a tornado just yet. It only gets that title the second that spinning funnel actually touches down on the ground. That's the moment the clock starts. That's when the real danger begins. Okay, so let's get into the crazy part. What would it actually be like to be inside one of these things? You'd think it's just total chaos, but it's actually a story of two completely different worlds right next to each other. I love this quote from one of our sources because it's just so perfect. It's like being inside a giant spinning straw. I mean, that really paints a picture, doesn't it? Just imagine that for a second. The walls of the straw are just a blur, spinning wildly all around you. And this really shows you those two zones. You've got the vortex walls, that's the chaos. That's where you have catastrophic winds and debris flying everywhere. But then you have the eye right in the center, and it's a totally different universe. The pressure drops like a rock, and the air can be weirdly, eerily calm. It's this tiny pocket of peace right in the middle of all that destruction. So we know how they're born, and we have an idea of what it's like inside. But how do you even measure the power of something like this? I mean, how do scientists put a number on that kind of raw, destructive force? Let's just start with one number, 400. That's 400 kilometers per hour. The winds in the most intense tornadoes can top that. To put that in perspective, that's way faster than a high-speed train. It's the kind of speed that doesn't just damage things, it completely obliterates them. And if you want to know what that speed really means, just look at what those winds can pick up and throw. I mean, it starts small, right? Dust, branches, but before you know it, we're talking about chunks of roofs, bicycles, even cars. Everyday stuff turned into lethal projectiles. So how do they rank them? Well, scientists use what's called the Enhanced Fujita Scale, or the EF scale. And here's the really smart part about it. They don't actually try to measure the wind speed while it's happening because, that's pretty much impossible and incredibly dangerous. Instead, they work backwards. They look at the damage after the storm has passed and rate it based on that. So an EF0 might just mess up some tree branches, but an EF5, that's the top of the scale. That's a storm that can literally scrape a solid house right off its foundation. But here's the thing. As powerful as they are, they don't last forever. Nothing does. Every tornado has a life cycle, and at some point, that incredible energy just runs out. So how does a monster like this finally die?
It's actually a pretty simple process when you break it down. You remember that updraft of warm, moist air we talked about? That's the tornado's lifeblood. It's the fuel line. As the storm moves along, the funnel starts to get stretched out, it gets thinner, it tilts over. It looks like a rope fraying. And that movement basically cuts off its connection to that fuel source. Once that fuel line is severed, it's over. The winds die down, and the whole thing just disappears back into the clouds.
So there you have it, the birth, the incredible life, and the eventual death of a tornado. Yeah, it's a cycle of unbelievable destruction, but you know what? It's also a powerful natural laboratory. It really makes you think, and it leaves us with one last big question. For all the damage they do, what can these amazing, terrifying storms actually teach us about how our own atmosphere works?